Hi, this is 3.1, Solving Systems by Graphing. And so by the end, you should be able to solve a system of two equations and two variables by the graphing method. Let's review how to graph this equation. First, we need to put it in slope-intercept form. Subtract 5x from each side. Wow, that is sloppy. We get 4y equals negative 5x minus 12 divided by 4. Y equals negative 5/4 x minus 3. And now it's in slope-intercept form, so we can graph it. It crosses the y-axis, negative 3. We go 1, 2, 3, 4, 5 down, and 4 across. Or we can go 5 up, 1, 2, 3, 4, 5, and 4 to the left, 1, 2, 3, 4. And then we would draw this line. Hopefully I don't butcher it. So we all remember that, correct? Okay. So systems of equations are two or more equations in this form. And A, B, C, D, E, and F are all just numbers. And we have the variables x and y in each of the equations. Okay, so this is one equation and this is two equations. Now, when we find the solution to these two equations, it's going to be an ordered pair xy. Now, that xy is going to satisfy equation 1, and it's also going to satisfy equation 2. Also, when we graph equation 1 and we graph equation 2, they're going to intersect at this point x, y. So the solution is also the intersection point of these two graphs. Now, the solution will also satisfy both equations. So we're going to check whether 2, 2 is a solution of this system. All right, we need to plug it in and see if it comes out consistent. What am I doing? Okay. We're going to plug it into this equation first. So 3, and here's my x, so I'm going to plug x in here, minus 2y, and this is my y, equals 2. Now we just need to simplify. So 3 times 2 is 6, minus 2 times 2, which is 4, and that's 2. Now, does that equal the 2 on the right side of the equation? Yes, it does. So the ordered pair 2, 2 satisfies our first equation. Okay, now we need to see if it satisfies the second equation. So we're going to plug in this x to this equation plus 2y. Again, we plug in the y. And simplify, so 2 plus 2 times 2 is 4, and 6 equals 6. Okay, so that ordered pair also satisfies the second equation, and so we know it's a solution of this system. All right, now pause the video and try this one on your own. Okay, let's see if you got it. So we take our first equation, so this is equation 1, and we're going to substitute in our x value and our y value. So we get 3 times 0 minus 2 times negative 1 equals 2. 3 times 0 is 0, minus negative 2 times negative 1, positive 2, and yes, that equals 2. So we're good there. Now let's try our second equation. So we have 0 plus to -1 equal to 6. And 0 plus 2 times -1 is -2. Does that equal 6? No, it doesn't. So the point 0, -1 is not a solution to the system. Okay, that's why it's important to always check both of the equations. You can't just stop after one of them is a solution. If it doesn't satisfy both, then it's not a solution to the whole system. Okay, so now we're going to check the solution using a graph. So here are these two lines. It looks like this one is -x plus y equals 2, and this one is 2x plus y equals 8. And here is where they intersect. And we said that the solution to the system is the intersection point. So it looks like this is 2, 1, 2. We're counting by 2's here, so x value is 2, y value 4. And that's the ordered pair that satisfies the system of linear equations. We should always check that though. So let's plug it into the first equation. Opposite x, so we plug in 2 there, plus our y value, which is 4, equals 2. So does -2 plus 4 equal 2? And you always want to show the last step, so 2 equals 2. Okay, let's check the second equation. 2 times x, and our x is 2, plus y. Oh, just kidding. Our y value is 4. Change that to 4. Equals 8. 2 times 2 is 4, plus 4 equals 8. Show the last step that 8 equals 8. And we're good. Yeah, so 2, 4 satisfies our system. Okay, so the steps to solve a system using the graphing method is going to be 1, to rewrite the equation in slope-intercept form. So that means you solve for y, and then you'll graph both the equations on the same coordinate plane. And you're going to find their point of intersection. And then you'll have their solution. Okay, so let's try those steps. So step 1 was solve for y. So I'm going to do the first equation, which is 2x minus 3y equals 1. I'm going to subtract 2x from both sides. And I get -3y equals -2x plus 1. Divide everything by 3. -3. Oh, wow, excuse me. Y equals 2/3 x. Negative divided by a negative is positive. And I get -1/3. Okay, so I'm going to graph it at, my b value is -1/3, maybe somewhere in here. And I'm going to go up to 1, 2, and over 3. 1, 2, 3. Okay, or I can go the other way. 1, 2, 1, 2, 3. And I draw my line. Pretend that touches. Okay, that's line 1. Now I'm going to do equation 2, solve for y. So x plus y equals 3. Subtract x on both sides. Y equals -x plus 3. So I'm going to go up 3 on the y-axis. And I'm going to go down 1 over 1. draw this line here. And you'll probably want to be more precise than I was, because this intersection point is the solution, which it looks like 2, 1. We're definitely going to have to check that though, because it doesn't look accurate. Okay, so all we need to do is plug it back in. So equation 1, 2 times x, and our x is 2, minus 3 times y, our y is 1, equals 1. 2 times 2 is 4, minus 3 times 1 is 3, equals 1. 4 minus 3, 1 equals 1. Yay! Okay, and let's check equation 2. X, which is 2, plus y, which is 1, equals 3. Oh my goodness, miracle. 3 equals 3. So, winner, our solution is 2, 1. Okay, so try this one on your own. Go ahead and pause the video. Remember the steps, solve for y, graph both the equations, find where they intersect. You will want to check your answers. So ready, pause. Okay, hopefully you got the answer -3, 1. If you didn't, go back, see where you went wrong, and see if you can fix it. Okay, so what if our system turns out to be 2 parallel lines? Well, in that case, there's going to be no solution, because parallel lines never intersect. And remember, the intersection point of the lines in our system is our solution. Since there's no point on this graph that satisfies both equations, there's no solution. And we call this an inconsistent system. Alright, now I want you to graph this system of linear equations, so pause the video. Okay, hopefully you paused the video and you graphed y equals 3/2 x minus 3, and y equals 3/2 x minus 1. So your line should look like this. And you can see that these are parallel lines and they have no solution. So the system is inconsistent. Okay, so there's another case that you're going to encounter when you graph systems of linear equations, and that's when both lines are exactly the same. So if I solve for y on this second equation, I'm going to get y equals 4x plus 5. If you don't believe me, try it yourself, solve for y. And so that's the exact same line, right, as the first one. So when we graph it, both lines intersect at every single point, right? There's an infinite number of solutions. No matter what coordinate point we pick, it's going to satisfy both equations. So this is a consistent system, and it's also dependent. Alright, since I'm already a superstar, I'm going to let you graph this system. So go ahead and pause the video. Okay, so hopefully you paused, and when you solve for y in each of the equations, you got y equals 3/2 x minus 3. If not, go back, check your work. I think that's what you should get. So we're going to go to the -3 on the y-axis, up 1, 2, 3, to the right 2, plot that point. So that's equation 1, and equation 2 should have been the exact same. So I have the same line for both equations. That means I have an infinitely many solutions And again, it's a consistent, dependent system of linear equations. All right, so just to kind of review, if we have a system of two linear equations and we graph them, their intersection point is going to be their solution, and the solution is going to be a coordinate point, x, y. Okay, if there is one solution, the system is consistent, and it's also independent. Okay, and if we have a system of equations and the lines have the same slope, in other words, they're parallel, then we get no solution, and that makes the system inconsistent. And the last case is if we have a system of equations that give us the same line, then we have infinitely many solutions. Infinitely many solutions. System is consistent and it is dependent. I can't spell. Okay. Oh, one solution. Okay, that wraps up 3-1. Bring your questions tomorrow before the homework quiz.